Alright, 10:19. A factory worker pulls on a rope attached to a pallet loaded with a crate, dragging the combination across a rough factory floor. Draw a free body diagram for the pallet, one for the pallet and one for the crate, under two different conditions: when the pallet is on level ground and when the pallet is being pulled up an incline. The velocity is constant in both situations. So here's just a picture that I got off the internet. Here's a pallet, okay? There's a pallet and there is the crate. Okay, so for example, the factory worker is pulling on the pallet, okay, and then both the pallet and the crate move. So A is when the pallet is on level ground. So you've got, let's see if I can, so I'm just going to draw the pallet there and the crate there. Okay, so that's my crate and that's the pallet. Okay, so we need to draw free body diagrams. So basically, well, let's just there's the force, okay, but now we want to draw a free body diagram of the pallet and the crate. Okay, so I'm going to split these guys up. Okay, so there is the crate, there is pallet. So please try to do this on your own and then we can come back. Okay, so please try, take 5 minutes and try to figure it out, or 2 minutes. Okay, so this is the pallet. Alright, crate and pallet. Okay, so there's something very important here, and it says the velocity is constant. The velocity is constant. So, because it's sliding, we know maybe I can do black. We know that, well, let's just first say this is the force contact between the worker and the pallet. That's this force here that we've been talking about. But it's sliding across a rough factory floor. So rough means that we've got some kind of friction. So we know that there is this kinetic friction between the surface and the pallet. Okay, so that's what's happening in the x direction. Okay, we know also that we've got a force of gravity of the earth on the pallet. Okay, that's just your gravitational, that's your gravitational force. Alright, okay, so you should be able to have gotten those. What else is happening on the pallet? Remember, we're just looking at the free body diagram of the pallet. So remember, we've also got the contact force of the crate on the pallet. Okay, so this is a contact force of the crate on the pallet. Alright, so that's what we have for the pallet for now. Okay, now let's move to the crate. What's happening in the crate? Well, we know that there is also, I haven't aligned these up by the way, but yeah, this is force of gravity, earth on the crate. Okay, that's the force of gravity pulling the crate down. But then you've also got the force of a contact force. Remember, there's this contact force between the pallet and the crate, and it is an equal and opposite force. It is it's a force pair. Okay, so this guy, this is the opposite of this guy. So this now needs to be the crate on the pallet. Where hold on, sorry, this is pallet on crate. Okay, pallet on crate. this is the force, the contact force between that the pallet is exerting on the crate. Okay, so this one and this one are force pairs. Okay, so now you might be wondering, what about the static friction force? Because I'm applying this force and it essentially is causing this crate also to move in this direction, right? So you might say, well, okay, there should be a static friction force between these two. So I can go put in force, static friction force, okay? So it is understandable that we would think that there would be the static friction force. But remember, both these objects are moving at constant velocity. Constant velocity means our acceleration in the x direction is 0, which means the sum of the forces in the x is 0. Sum of the forces in the x direction is 0. So if if the pallet is going at a constant velocity, that means this force equals this force. And if the crate is going at a constant velocity, acceleration is 0, that means that if there were to be a static friction force here, then there would have to be an opposing force that cancels this force out or balances it. But there is no force acting in that direction. Okay? So, once it gets to this constant velocity, there is no more static friction force between the two bodies. Both these bodies are moving at the same velocity, and there is no static friction force. Alright, now let's look at the inclined situation. Okay, so the incline, I'm just going to quickly draw it here and there and there. Okay, there's the pallet and there's the crate, right? And the person is pulling it up like that. Okay, so let's break these guys up again. There's the pallet and there is the crate. Okay, so let's go and put in the obvious ones. We know that the worker is pulling it up like that. It's a contact force of the worker on the pallet. So that's the pallet and that's the crate. We know that we've got gravity, right? Force of gravity, earth on the pallet. We know that we've got this contact force of the crate onto the pallet. Okay, contact force of the crate onto the pallet. And because it's sliding, we know that we've also got kinetic, right? Kinetic friction. Did I put that in previously, right? Yes, that was kinetic. Okay, of the surface onto the pallet. Okay, so as you can see, it's very similar to this one. If you look here, we've got these two forces and we've got those two forces, and those two forces. Okay, but we'll see there's some slight differences and important differences. Okay, now what's happening on this crate? Well, we know this tablet is not so easy to always draw on, so you just close that up. Okay, so we know we've got gravity, earth on the crate, right, pulling the crate down. We've also got this guy's equal and opposite force, F, contact, but the pallet on the crate. This was the crate on the pallet. This is the pallet on the crate. Okay? Now, this is where it gets interesting. Because if you look at this object, the crate, you can see that if you just had these two forces, right? you can see that this gravitational force, that's gravity by the way, this gravitational force has a component in that direction, right? It has a component along this x direction, and it has a component in the y direction. So if we just had this free body diagram for the crate, you can see that it has this component here, which is your gravitational component in the x direction, which means that our sum of the forces equals that which is not 0. So if we just had this guy, then it means that it would be sliding down. There would be an acceleration down. Okay? But the question says it's going at a constant velocity. It's going at a constant velocity. So if it's going at a constant velocity, it needs a counteracting force so that the sum of the forces in the x are equal to 0, which means that our acceleration is 0. So it needs another force in that direction. And what would that be? What would that be? That would be our static friction force of the pallet on the crate. Okay? So I'm just going to erase this now because we've got double forces there. Okay? Oh, it's difficult to draw with this tablet. Okay, I think you guys get the idea. We've got this downward gravitational force, and to counteract that component of gravity, we need the static friction force that's being applied there. So now we've got this component and that force, and our acceleration in the x is 0. But then because we've got this static friction force over here, we need to counteract it with the static friction force on this body. So it's static friction force of the crate on the pallet. Okay, so that is the slight difference between these two. Okay, and these are cases when we have constant velocity. Okay, hope that makes sense.